Hello guys, today we're gonna be dealing with mechanics, meaning forces and Newton's laws. So in summary, this section covers important aspects from the grade 11, meaning kunomsebenzi wakwa grade 11 up. So you must try by all means to understand everything that you did from your grade 11 that has to do with vectors and scalars. So now we're gonna be dealing with vectors and scalars. Alright, looking at those definitions, you must just understand those definitions, but I will suggest that, for example, you must look from examination guidelines. For example, these ones are from examination guidelines of 2021 physics. So you must just look at your examination guidelines before you answer any question. You must study through examination guidelines. So that is it. Let me make an example. For example, here, this is the study guide, Mind the Gap, Physical Sciences. So looking at that number 8, which is Newton's law of universal gravitation, here it says a force of gravitational attraction exists between any two particles or objects anywhere in the universe. So we all know that that force will be directly proportional to the product of the object's masses and will be inversely proportional to the square of the distance between their centers. So let's go to the examination guidelines of 2021, meaning what do they want or what do they expect from their examination from us as students. So here the Newton's law of universal gravitation will say, where is it? Oh, here it is. Newton's law of universal gravitation says each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So luckily here is the formula. You will solve the problems using the formula. Force is equal to the gravitational constant multiplied by the product of their masses divided by their square of their distance, meaning r squared. That is it. I was just making an example. So let me quickly go to our revision of vectors. So from our vectors, you must just know what is a vector and what is a scalar. Hopefully in your examination guidelines you will see something that says a vector is a quantity that has both magnitude, meaning size, and direction, whereas a scalar is a quantity that has only magnitude. So even if they can wake up you around 12 a.m., you must just come up with an example of a vector as a force, and example of a scalar as a mass. Let me quickly show you the examples of vector and a scalar. Wait a minute, wait a minute. Let me quickly show you the examples. All right, here they are. Scalar examples, you will see the distance, speed, mass, time, energy, volume, density, pressure, electric charge, temperature. Then vectors, displacement, velocity, acceleration, force, momentum. Those are the vectors. So I was trying to show you those vectors. Then therefore vectors are represented by an arrow. We all know that. We all know that. Then therefore, to resolve our vectors, we must just know that we have two methods from our grade 11. From our grade 11, we all know that we have a triangle method and a parallelogram method. For us to solve our vectors, we must know that we have this method, a triangle method, and a parallelogram method. So you can just stop the video and take a screenshot first, because it's just the revision from grade 11. That is it. That is it. That is it. And you must just know the definition of a force, that it's a push or pull of an object. But you must just define following through your guidelines. I think I should end this video of vectors and scalars here, because it was just a revision from your grade 11. I'm signing out.